Unit 8, Lesson 1, Investigation 2, Conditional Probability. Like I said, copy on this table, and then the probabilities that you can figure out, try to figure those ones out. Now the ones with the lines, these are conditional probability. We're going to learn about those today, so you cannot do the ones with the lines unless you've been reading ahead. And if you've been reading ahead, great. Hopefully we understand. I do. I know. We already said that's odd. We got that already. All right. Probability of wearing sneakers. Looking at our table, what's the probability that somebody's wearing sneakers? 13 out of 28. Good. So total number of sneakers over the total number of people. So 13 out of 28. Probability of a girl. What's the probability that someone is a girl?
3 7.
What is it? 3 7s.
12 out of 28.
Okay. All right. So the total number of girls is 12 over 28. Good.
You want us to reduce?
Yes, if you can reduce, please reduce. All right. Last one, probability of girl and wearing sneakers. Which number is this? Which box am I looking for? Okay. Girl and wearing sneakers is this box right here, right?
Mm-hmm.
And that is a 3 in that box. So the probability that someone I select randomly as a girl and wearing sneakers is 3 out of 28. Now this data I obtained yesterday during one of my hours while people were working on their worksheet. I went around and counted who was wearing sneakers and who wasn't. Now I counted sneakers as any shoe that had ties and rubber. Okay? So if it was Converse All-Stars or skate shoes, same thing, I call them sneakers. Okay? Ties and rubbers were my defining characteristic. Right? Alright, so here's some good data for us to use. Any questions about how we got these probabilities? Any questions? None? None? Okay. Now, girl and wearing sneakers. What does that mean? What am I doing? Am I looking at the whole population or just a part of it? As my total, am I using the whole population or just the part? The whole, right? When we're doing the probability of a girl and wearing sneakers, that means I'm looking at the whole population and I'm finding the girls and people who are wearing sneakers, right? Right? So the person would have to be a girl and have to have sneakers on or shoes with ties and rubber on them in order to be counted in that one. Okay? Now, conditional probability is different than and statements. Okay? Conditional probability is where we take our population and we section it off based on conditions. Okay? What could be a condition in this data table?
Girls with sneakers.
Nope, that'd be like a whole event. What could be a condition though? That you're a girl, right? If I say we're looking just at the girls, okay, that means I'm taking all the boys in the population and I'm telling them to leave the room or go to the back of the room or wherever, and I'm just going to look at the girls' shoes, right? And then from there we could talk about who's wearing sneakers and who's not, right? And I'd be doing conditional probability then. Okay, so if I'm looking just at girls' shoes, what would my total number be? 12, right? Just at girls' shoes, my total number would be 12, right? Okay, so if I'm looking only at the girls' shoes, then what's the probability that they're wearing sneakers? 3 out of 12. Okay. That'd be saying, that's saying if they're girls, what's the probability of wearing sneakers? Right? If I was looking just at the boys' shoes, what's the total number of boys? 16. What's the probability they're not wearing sneakers? 6 out of 16. Okay? And we're going to go through how we get those in a second. I could also divide them based on their the shoes they're wearing, right? I could say, everybody who's not wearing sneakers, go to the back of the room. I'm only going to look at the people wearing sneakers, right? And I could say, of the people wearing sneakers, what's the probability they're a girl, right? So if I'm looking just at sneakers, what's the total number? 13, right? The total number just wearing sneakers is 13. So what's the probability that of the people wearing sneakers, that one of them is a girl? 3 out of 13. Okay? You guys are doing conditional probability. So basically what you guys just did as we work those numbers is what we're doing today. Okay? And I'll explain it more in depth, so if that didn't make sense, we'll go through a little more in depth. Now, conditional probability has a nice equation for us to use. Okay? So the conditional probability of A line B. Basically, what this is saying is the probability of A if B. Of A if B. Right? Or it's also asking for the probability of A in B. So it's the probability of A in B or the probability of A if B. Now the equation for this A and B, sorry about that, over the probability of B. So the probability of A if B, or the probability of A given B, is the probability of A and B divided by the probability of B. Now I'm going to show you how that's the same as what we were just doing. Okay? I'm going to show you how it's the same as what we were just doing. Okay. Are you guys with me? You guys with me? Yeah? Okay, this first one. This is probability of girls if sneakers, or the probability of girls given sneakers. Right? So, how am I dividing my population up?
It's just a girl.
Am I looking at all the girls first, or am I looking at all the sneakers first?
Girls. No, sneakers.
Sneakers first. Backwards. Okay? A if B is backwards. It's saying we're starting with the B's, and then we're looking for A. Okay? So we're starting with sneakers, and then we're looking for the girls. Okay? So, how many sneaker wearers are there? 13. How many of them happen to be girls?
3 out of
3. So what you can do is we can look at the table and say, there's 13 people wearing sneakers, 3 of them are girls, so my probability of girl given sneakers, or girl if sneakers, is 3 out of 13. It's kind of like what you guys wanted to do initially when we were talking about and statements, wasn't it? Yeah. Now I'm going to show you how that equation works. Okay? Because the equation works the same way. On top, it's going to have the probability of A and B, meaning the probability of girl and sneakers. Which number up here is girl and sneakers? 3 out of
12.
28. 3 over 12.
Oh, I got it.
Okay, 3 over. Okay, we'll get to that in a second. It's 3 out of 28, right? So if I'm going to use the equation, we're going to have 3 over 28 over the probability of B. Well, B in this case is what? Sneakers. What's the probability of sneakers? 13 over 28. And now we get to use a little bit of cool mathematics. And then you're thinking, we have a fraction divided by a fraction? It can be confusing, right? Now, do you see something that's on both the top and the bottom? 28. 28's on the bottom of the top, right? And the bottom of the bottom. So since 28's on the bottom in both, what can we do with it? Cross them out. So this becomes 3 over 13. So either way, we get the same answer. Because 28's on the bottom of the top and the bottom of the bottom. Yep. As long as it's in the same spot. If 28 was on the bottom of the top and the top of the bottom, then we couldn't cancel. Okay? But since it's on the bottom of the top and the bottom of the bottom, we can cancel.
And that's every time?
Every time. And with this one, you'll get a lot of bottom, the numbers being the same on the bottom of the top and the bottom of the bottom. All right, any questions? Now, Davion, do you think sneakers, if girls, is going to be the same as girls if sneakers? No? You don't know? Okay, let's think about it this way. How am I separating first? Girl. So I'm saying, I'm only looking at the girls in the class, right? So, how many girls are there total? 12. Right? Different than 13, isn't it? Okay, so 12. How many girls are wearing sneakers? 3. So this probability, is it 3 out of 13? No, it's 3 out of what? 12. So does the order we write them matter? Yes, because we get different answers, don't we? Okay. Now if you're using the equation, it'll give us the same answer. We'll walk through that step too. So probability of A and B. Probability of sneakers and girl. Sneakers and girl, same thing we got right here. 3 over 28. Probability of girls on bottom. So probability of girl.
13 out of 20.
No, that's sneakers.
12
12 out of 20. I appreciate the effort though, John. Now, 28's on the bottom of the top and the bottom of the bottom, so we can do what? Some outs. And we get.
Is it always going to be like that?
Yes, it'll always be like that. Well, I'm not going to say it'll always be like that. Most of the time in this class, when we're actually using the equation for this, then the bottom of the top and the bottom of the bottom will be the same. Most of the time. Okay. Now there might be a time later where I give you a probability distribution and we work from there. Okay. Like I don't give you the table. All right. Any questions? Any questions? All right. I want you to try boy if not. Now not. I was using shorthand. That means not wearing sneakers. I'd like you to try boy if not on your own. Boy if not. Try that one on your own. Okay, so boy if not. How am I dividing first? What am I looking at first? Boys are not wearing sneakers. Not wearing sneakers. It's seconds, that's what I'm looking at first. So how many total are not wearing sneakers? 15. How many of those are boys? 6. So then what's my probability? 6 over 15. Now if you're an equation person, which I like to think I am, right? I'm gonna try it out using the equation. Alright, so probability of A and B is probability of boys and not wearing sneakers. So, which number up here is boys and not wearing sneakers? 6, right? So we're going to have 6 over 28, because that's the probability of boys and not wearing sneakers, right? And what's the probability of, what's the probability of not wearing sneakers? What is it? 15 out of 20. Okay, 15 out of 28. So that means we'll cancel, and we get 6 out of 15. So you can go either way. Now, personally, if I was in your shoes taking this test, I'd be using the equation every time because I would think that the equation. I mean, just being the person I am, I like equations. But you can go either way. Right? It's also a good way to check yourself too. Okay? Try using the table, then use the equation, or use the equation, then use the table. Right? Good way to check yourself. Now, a couple cool things about conditional probability. Well, I think they're cool. Usually when I think they're cool, it means you guys don't. That's okay. Right. Conditional probability. Let's say A and B are mutually exclusive. So if A and B are mutually exclusive. If A and B are mutually exclusive, then what's the probability of A and B? What is it? 0. They're mutually exclusive. They can't happen at the same time, right? Yeah. So this is 0. So then what does that mean for A if B? A and B is 0. What does that mean for A if B? 0? Why is it 0, John? 0 on top, right? Doesn't matter what this number is. If this is 0, the whole thing's going to be 0. So if A and B are mutually exclusive, then A if B is 0. Second cool thing, if A and B are independent. Now remember, independent and mutually exclusive are not opposites. Okay? Some of us have been thinking they're opposites. They're not. Okay? So if A and B are independent, then what happens to this? If A and B are independent, then what happens to this? Quick little math. If A and B are independent, then this can be written as P of A times what? P of B. And if I have a P of B on top and a P of B on bottom, what happens to it? They cancel out. So then what does this equal? Just A. So if A and B are independent, then P of A equals P of A if B.
You're hitting us with a lot of A's and B's.
I know. So let's see what that means. All right, let's see what that last independent part means. Okay, so let's go back over here so we can see our data table and our independent stuff. Okay, earlier, guys, we calculated the probability of wearing sneakers, the probability of girl, right? Right? So my question is, are these independent?
Yes.
Are they independent? Okay, Bree, how do you know? Okay, a little louder, I can hear it.
You can't tell by the table.
Okay, we can't tell by the table, but you sure?
What was the answer?
Because remember from down here, it says the probability of A equals the probability of A given B, right? That means they're independent. So here are the probability of girls and sneakers, or girls if sneakers, right? So if this equals the probability of girl, then they're independent. Okay? So if probability of girl equals the probability of girl if sneakers, then they're independent because it matches this equation, right?
But they're not.
So does 3 over 7 equal 3 over 13?
No.
No. So are they independent? No, because they don't equal. 3 over 7 does not equal 3 over 13, so they're not independent. Okay?
So,
Using this down here,
Mhm.
right?
Mhm.
So in our case, probability of girl equals probability of girl if sneakers, right? Here I have probability of girl.
Mhm.
Here I have probability of girl if sneakers. Are they equal? No. So it's not independent. Okay? We could look at the other way too. We could say the probability of wearing sneakers equals the probability of wearing sneakers if girl, right? So then we compare 13 over 28 to which one?
3 over 12.
3 over 12. Does 13 over 28 equal 3 over 12?
No.
No. So is it independent?
Nope.
Does that make sense?
Yeah.
Are there any questions? Any questions? Really? Any questions?